exponents or powers. The learning goal for this lesson is that I can represent and calculate numbers expressed as powers. When we refer to a power, we mean a number, which is we call the base, with an exponent. The base and exponent together form a power. As you see in this diagram, we've got a base in this case that's 2, an exponent that's 7, and together they're referred to as the power. So we've got a couple examples here. 2 times 2 is the same as saying 2 to the exponent 2, or 2 squared. 2 times 2 times 2 is the same as 2 to the exponent 3, or 2 cubed. A power means multiply the base by itself as many times as are in the exponent. In this case, we've got 8 2's multiplied together. So 2 to the 8th can be expressed as 2 times 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 2. So we've got a total of 8 2's. So 2 cubed is 2 times 2 times 2, which of course 2 times 2 is 4 times 2 is 8. 5 cubed is 5 times 5 times 5, which is 5 times 5, which is 25, times another 5 is 125. 2 times 8, as we said, was 2 times 2 times 2 times 2, and so on, which if we multiply it out, 4, 8, 16, 32, 64, 128, 256. When working with powers of 10, the exponent tells us the number of zeros. So in the case of 10 to the exponent 1, it tells us there's 1 0 following the 1. 10 to the exponent 2 is 10 times 10, so there are 2 zeros following the 1. And so on. 10 to the exponent 3 is 1,000, which shows that there are 3 zeros following a 1. And 10 to the 4th is 10,000, with 4 zeros following the 1. If we multiply a number times 10 with an exponent, the exponent tells us how many zeros to add to the end, or more accurately, it tells us how many decimal places to the right the decimal needs to move. Let's look at an example. 45 times 10 to the exponent 2 is the same as 45 times 100, and if we then go ahead and do that multiplication, we'd have 45 times 100. That's the same as taking 45 and moving the decimal place, which is sitting right here, we don't always write it in, and moving it 2 positions to the right. There are 2 zeros, so we're moving it 2 positions. So we add 2 zeros at the end, so the answer would be 4,500. If 2 times 10 to the exponent 2 is the same as 2 times 100, which is 200, then we can go on and look at a more complicated problem, and we can see that 5 times 10 to the 4th is the same as 5 times 10,000, and 5 times 10,000 would be 50,000. And again, we can see the connection here of the exponent 4 and the fact that there are 4 zeros following the 5. Now let's look at a slightly more complicated number. You've worked with decimals in the past. Now we've got decimals again for this type of problem. We've got 3.2 times 10 to the 3rd. The 3 exponent tells us that we're going to move the decimal place 3 positions. So it's not so much about adding zeros this time as we're just moving the decimal place. So if we take the 3.2, we can see the decimal place is there, and we're going to move it 1, 2, 3 positions, and we'll fill in those spaces with zeros. So you can see that that gives us the answer of 3,200. Similarly, for 4.01, this time we've got an exponent of 4, so that tells us we're moving the decimal place 4 positions. 4.01, we're going to move the decimal place 1, 2, 3, 4 positions, filling in the extra spaces with zeros. So our final answer is 40,100. And one more final trick. We've got 7.3147, and we've got just an exponent of only 2 on the 10th. So that means we're only moving the decimal place 2 positions. So it's going 1, 2 positions. So we end up with some of the decimals left over. We don't have to be adding in zeros. So that's how we get the 731.47. One more important fact. Any number raised to the exponent of 0 is always 1. So 10 to the exponent 0 is 1. 5 to the exponent of 0 is 1. Or 137,509 to the exponent 0 is still just 1. Now it's your turn.